Hello, this is George, and this is a demo on my latest project, TS-ParamScape3D. Lately, if you've been following my blog post and things I've been doing in my Easing into Easy Language Academy, I've been developing software to do data visualization on different parameter sets. I showed in one of my previous Easy Language Academy modules, I guess it was module 3, I showed you how to do a three-dimensional plot. That TradeStation doesn't have that capability, but I provided that capability via a piece of software. But I wanted to go beyond that. I wanted to be able to plot multiple parameters, not just two. If you plot two, you have to have a 3D surface. If you plot three parameters, you would have to have a 4D surface, and if you have four parameters, you'd have to have a 5D surface. And we don't have that capability of 4D or 5D surfaces. So I came up with this idea, and it's a very simple idea, and I'm going to show you how this software works. You just go into TradeStation as you normally would and do an optimization. I've got a strategy here that I want to do an optimization on. And basically, when you do an optimization in TradeStation, it will keep probably the top 500 to 1,000, but you need to keep as many as you can. So if you need to go to, you probably have to go to Settings, go to your Preferences on any of the chart windows, and you want to set your optimization report settings to keep the highest 8,000 tests. It's got to be 8,000 you want as many as possible. If you go over 8,000, you'll get an error message. And I optimize this strategy, and this strategy you will get with the if you get the software. I give a strategy out that you can use, to test and use for the software. And this is a mean reversion system. It's called Euclid. It's a system I developed in late 2017, early 2018, and we actually used it on managed accounts. The version I'm giving away is a open version. It doesn't have all the proprietary software in it that I had when we managed money on it. But you know how to do an optimization in TradeStation. You go to Studies, you go to Edit Strategies, and I'm just going to show you how to do this real quick. And you want to keep your numbers below 8,000. So if I optimize these preset values, I will get, it should have remembered, just ignore that. That's just saying you're going more than 200 bars back. We're doing dollars, not bars, so it doesn't matter. And we're going to go ahead and hit OK. And we're setting this optimization up. And we can hit OK here. And it's got 6,318 optimizations. So you can go ahead and run your software, your optimization. And I'm doing that. But we'll do some other work while that's working. That's going to be about 2 minutes. And I want to keep this video fairly short and sweet. You'll get the optimization report, and I've imported it into Excel. And I'm going to show you what I was thinking when I first started to develop this software. If you do a 3D surface chart, you can only plot one point for each XY. So say your moving average is X, and your stop loss in this case is Y. So if you plot 40 and 1500, you should only have 1 point for your net profit. But since we're doing optimizations more than just the 2 parameters, we're doing actually 4 parameters, you will get this many points that are located at the same XY, 40 and 1500. So you get all these. There's 66 of these different results at that 1 point on the surface chart, and you can't have more than 1 point on your surface chart. So what I decided to do, I said, well, why don't we plot the 40 and the 1500, but instead of just plotting this 1 point, let's plot the average of all these points together. So what I'm doing basically is I'm reducing the all these points down to a single point by using an aggregate function such as a moving average. So if we plot this and this average, then we can produce a three-dimensional chart. And the average return for 40 and 1500 across these different other parameters will give you kind of an idea of how robust these two parameters are. If they do extremely well across all these 66 different iterations, then it must mean it's a pretty good, robust parameter set. So that's what got me started on the ParamScape software. So let's see if we're done with the optimization. Go to TradeStation, and we're almost done with that. Okay, we've got a few seconds left, and here we've got the net profit up to $198,520 with the moving average length of 140, 2,000 as the stop loss dollars, and 7,000 for the stop amount dollars, and the ATR mult is 1.5. Now, those are the best parameters, and we don't know if that best parameter set is the most robust parameter set. It could be that those parameters are right on a peak. So that is the benefit of this software I'm going to show you, is that we can go in there and see what the best parameters are and see if those fall onto that, what I call a plateau. So we're done with that. So what you do is you bring up your optimization report, and since we're saving 8,000 iterations, it takes a couple moments for this to come up. So we'll just give it a second here, and then once it comes up, we will save it as a text file. That's the only option that TradeStation gives you, is to save it as a text file, but it's a special text file. It's a tab delimited text file. So each of these columns is separated by not a comma in most cases that you would expect, but a tab. So it's a little different. So all you got to do is just save this data out to a convenient location. I've got a folder called XML files demo. You could just save it right to there, and I've already done this several times, so I won't save it and right over what I've already done. So that's how you save your data out. And the TS-ParamScape, you just go into your start menu and you launch it. When you install it, it will come with a shortcut on the start menu and also on your desktop if you want it to. So first off, I'm going to do that surface averaging, and the z-plot type is going to be mean. Okay, that's going to be, instead of the absolute point value at x and y, it's going to be the mean of those 66 iterations at each x and y. So I'm going to go ahead and set my target. What I want the z to be is the net profit. I could do the maximum intraday drawdown. I could do average trade. Whatever's in your TradeStation report, you can utilize. So we'll do all net profit, and let's go ahead and plot that. I'm going to plot that with Plotly. Plotly will launch a browser window, and it will plot it for you. And the reason I also give you the ability to do it with Matplotlib, which is really fast. It's super fast. I'll do that as well real quick, and you basically will get the same thing. The Plotly is just a better looking curve, and I like how the cursor tracks. So you can do the Matplotlib 3D surface, or you can do the Plotly. And here's the Plotly, and here is the mean. And our best parameter set, if we go back, was 140, 2,000, 7,000, 150. Let's look at our Plotly. And if you look up here, there's the 140 and the 2,000 and the 2,500. You can see that 142,000 is sitting right there on that plateau, right there. Okay, so that's probably a very good parameter set, because we're not just plotting one point, we're plotting the average of 66 points. So starting out, the 140 and the 2,000, and if you want to do, you could re-optimize and say, hey, I want to fix these two parameters at 140 and 2,000 because I think they're going to be very robust. So that's really a cool feature, and that's what got me started. And I said, well, that's pretty cool. But then ChatGPT, who I was working with, came up with this really cool chart I've never seen before. It's called a volumetric chart or plot, volumetric scatter plot to be exact. So let me show you how that works. It's really interesting. So I'll go back over to my program. Let's make sure I got the right one. This time I'm going to show you how I can show you all 6,000 points, one for each iteration of the optimization search space at the same time. It's a really cool feature. So the way you do that, you got to set the z-axis as the other parameter. In this case, it's going to be the profit amount. So X is the moving average length, Y is the stop loss dollars, and the z-axis is going to be the profit amount. And I want to color my parameters based on how good they perform. If it's a light yellow, it's going to be good. If it's a dark purple, it's going to be a bad performance. And then I'm going to add that fourth parameter, and that fourth parameter is that ATR mult. Okay, so we're going to size. It's called encoding and markers. And the way I'm going to encode that is I'm going to make each of those parameters, or each iteration of that parameter of the open ATR mult, which I think I iterated over six different values. I'm going to make that a sizing. I'm going to encode it with a sizing function. So let's go ahead and plot the volumetric scatter chart. And this can only be done in Plotly, this volumetric chart. And if you look at it, you'll probably see, wow, man, that's a cool looking cube you got there, George. And there's different colors in there, and there's purple, and there's blue, and there's green and yellow. But you can kind of see, based on the, if you look at the Euclid stop loss, the smaller the value, you see more of a green tone here. And if you look at the moving average over here, where that green tone was, is more toward the longer length. And then you've got the target profit, which is the z-axis, and you can see that it kind of is more yellow, lighter colored as you go up the chart. So that's kind of cool, but it doesn't really tell you too much. What really is really cool is when you zoom into this thing, and you can do that with Plotly. So I'm going to zoom in, and I want a yellow color. So I'm going to move this chart down. I'm going to tilt it up, and I'm going to zoom in. And once you zoom in, you start seeing these clusters, and they're kind of look like a hot air balloon. And so what I'm doing is, for every XYZ address, I have, if you go back over here, so if I have 140 at 200 at 700, 140, 2,700, that's your XYZ. And I've got one there, so I'm going to see if I can do this. No, I'm in the wrong program. Sorry about that. Let's go to Excel spreadsheet. We can go ahead and we can get to the very top. We have that one. Let's go ahead and color that. Where's our second one? So we'll go to 2,500. There's another one. Let's color that. And you can go down through this, and you will discover, let's see, 40, 1,500, 2,500. You will discover that there are 6 of these occurrences. 40, 1,500, 2,500. We've got 2 more, I think. And there's the last one. 6 of them. You have 6 points. And what separates them, all these 3 columns, they're the same, 40, 1,500, 2,500, but it's the ATR mult that's changing. Okay? And then what we're going to plot by the color is, and size, we're going to plot the color of the movement of the net P&L right here. I'm sorry. So we're going to look at these values in that volumetric chart. So let me go back over there real quick. So what you're seeing is those 6 occurrences. I need to get this down just a little bit more. and I'm going to tilt it up, and I'm going to isolate one of these. There it is. There's a good one right there. I'm going to put it right in the middle of the screen. It's right here. Okay, I'm going to zoom in on it some more, and I'm going to move it down, and here you go. Here's those 6 values. You've got, this is using 155, 2000, and 9500. Those 3 values will stay the same for each of the plots I have on that cluster. The only thing that's changing is that 4th parameter, which is the ATR multiplier, the 2000. 2.0 goes 2.0, 175, 150, 1.25, and 1, and then you have the little purple, which is 0.75. The best in this stack, this cluster stack, was using a ATR of 1.5. And it seems like all the balloons, if you look at them, the hot air balloons, the purple is always at the very bottom. So that tells you that a smaller ATR is not a good parameter. And we ought to probably optimize from 1 or 1.25 on. So that's the cool feature of my volumetric plotting with the TS-ParamScape. But I've also got another feature that this is more of a visual display. I've also got a statistic-specific ParamScape. I call it ParamScapeRank. And let me go ahead and run that real quick for you. That takes a couple moments to launch. It's a very sophisticated program, but it's just so wonderful to see. I don't know if you've ever seen anything like this. I really had never seen a volumetric chart like this, and where you could go and you have the power of Plotly to really sink down in there, and you could just go forever. It's like a fractal. The closer you get, the more detail is shown. So we can zoom all the way in there. So that's, like I said, that is ParamScape3D. That is the first part of the tools that I'm going to provide. And as soon as this other one launches, I'll show you how it works. So we're going to go ahead and load that Euclid up. I think it's 4 I was working on last. And it's the same file that we had earlier. It's the output from the TradeStation optimization. And basically, and I'll go over this real quick. I won't go over all the statistics, but I just want to let you know that these tools together should be used in concert. You've got the visual display to help you determine what is robust in the surface display, and then you can go ahead and go into each plot of those 6,000 iterations of the optimization. You can examine each plot individually. And we did that by aggregating the 4th and 5th dimension. Okay, this tells you, this is RF. This RF stands for random forest, and you may not be familiar with random forest. It's just a model that is artificial intelligence that can go in there and see nonlinear correlation. The absolute correlation, that's using the Pearson, and that's a direct linear correlation. So this parameter, the ATR mult, has a very high impact. This is the strength of that parameter. And it's high mostly because we started at such a low value, 0.75, when we optimized up to 2. The 0.75 produced very, very poor numbers, whereas the higher numbers created some very good performance numbers. So that range of this parameter had a very large impact on the output. Okay, so that's what that basically is telling you. The stop loss, the range that we tested, it really didn't have that much input. You could go with a $2,000 stop or a $4,000 stop. It didn't have that much impact. The same for the moving average length. It didn't have that much of an impact, and neither did the profit amount for the range that we utilized. Now we could change that. If we expanded the range, the importance or the impact of that parameter may become greater. So we got the random forest importance, we got the absolute correlation, and we also have what this called a plateau. And the plateau tells you how forgiving that parameter is. A 0.200 or 0.2 it's not a very forgiving plateau. It's not on a plateau, meaning that you have to get that parameter. Its neighbors don't forgive very much. So it's kind of peaky. It's on a peak. It's brittle. So is the stop loss. It's kind of brittle as well, 0.125. What's not brittle is the moving average length. That provides a nice wide plateau of performance. What's really tremendously brittle is the profit amount, the dollars. It liked a certain value. Anything probably between 5,000 and 6,000 were going to be your best numbers. So that point is very brittle. It's on a peak. Okay, and you have to have a certain amount of values, and it's unforgiving. You got to get that parameter right. We have this thing called a knee, and a knee basically tells you, hey, from what I've seen of the input and the output, can I determine with some level of certainty where this thing levels off? Where did we see the inflection? Where did the utility start diminishing before 0.75? Was there any utility? Is there any utility after 2.0? And this will tell you the strength of the ability to perceive that inflection point on that diminishing return curve. And with the ATR mult, we have a 0.411, which says, yes, you can definitely see the inflection point. With the stop loss, it wanted a very small stop, not extremely small. I mean, a reasonably sized stop of 2,000 to 2,500 or 3,000. So in that small range, you really couldn't see an inflection point. Okay, it's 0.113. In the moving average length, there was a very easy to see inflection point, and that occurred on any moving average that was below 100. Anything below 100, it bent down. So you could definitely see an inflection point in the diminishing returns curve, and the same goes for the profit amount. It liked 5 to 6 to 7,000. Anything below that, the return went south. So that, using those two tools, I almost forgot my suggested ranges. Python is so powerful. Once you do your analysis, and you can use the top 10% of your returns, which it automatically does, it'll suggest what starting point you should re-optimize at if you do re-optimize. So here we should start at 1.5 for the ATR mult. The moving average length should be 150. We should start the profit amount at 7,500, and then the stop loss should be 2,250. Now that's not the best parameter sets. It's just suggesting, based on what it's seen and what it's perceived to be important and the impact of the parameters, maybe your optimization, if you do re-optimization, start at those points. And then it tells you something about the sensitivity, it tells you what the trend is, and all that's in the manual. But I just wanted to give you a brief demo of how the TS-ParamScape, the two tools that comes with TS-ParamScape, TS-ParamScape3D, and TS-ParamScapeRank work. I hope you enjoyed it, and like I said, I'm going to be offering these for sale at my website, georgepruitt.com.